Okay. We get a response. So that's the whole point of Gemini. You can implement a simple client in roughly 2 hours. Roughly 2 hours it took us to implement a simple... This is a simple client, basically, because now there is a bunch of links in here. Here is a Gemini link. So essentially you have to take the base link, append to this thing, and then continue browsing. So you can already do a basic browsing like this. We got the next one. Here is a bunch of other links. Right, so I can take this document and query that specific document. Like, I don't even have to have an interface, command line interface. I can just like modify the code directly and get the data. So that's kind of the whole point of Gemini, is to be this very distilled basic version of the web, the original idea of the web, of the interconnected documents. And if you want a fancier client, well, you can work on a fancier client. It's kind of cool that this client doesn't even have command line interface, and to go to the link we have to modify the source code. That's the whole point. Isn't that cool? So it's kind of a suckless, but it's also kind of like a apocalyptic style tech, right? Where you stuck with the laptop, but you don't have the client for the web. So you just like, you know, sitting in the basement and quickly writing up your own client and then just using it to gain more information, gain more software, and kind of bootstrapping yourself. Because for the actual web, you need like a full-blown browser and shit like that. But here you can just like write up your own client. That's a cool idea for a game. Yeah, that's a pretty cool idea for a game where you can connect to the network and you have to write the first client, and then through that network, through that web, you gain more documentation and more software to access more different things and stuff like that, and eventually you hacking into some sort of like a data center of the AI that took over the humanity or something like that and blew up a nuclear plant to destroy that AI or something like that. Post-AGI programming games, yeah, something like that. Hello everyone, and welcome to yet another recreational programming session with Ahu Mr. Azudin. So, do you know what is a Gemini? No, it is not the shady AI by Google, but some time ago, Gemini actually meant a very nerdy protocol that is meant to replace HTTP. Right. So, and it's actually designed to be super simple, and the main goal is that you can even create a client like super quickly, maybe in one evening or something like that. There's a lot of sort of like a website or Gemini spaces, I don't remember how they're called or something like that, to test your client on. And I just thought that sounds like a pretty good recreational programming exercise. Right, and I haven't programmed in Jai for some time. The last time I programmed in Jai, I was just like porting my old game to the latest Jai. But I kind of want more. I kind of crave more of Jai programming. So I think this is like a perfect exercise, perfect excuse to program in Jai a little bit. So, and we don't even need that much to implement like a very simple protocol. So what I want to implement today is probably to establish a connection to a Gemini website or a like pod. I think they're called pods or something like that. They have their own weird terminology. Just, you know, make a query and receive a Gemini document, right? So they also have their own, you know, format for the documents, and it's not HTML, it's Gemini text or something like that, and it's actually reminiscent of Markdown, but it's not exactly Markdown. So there's some sort of limitations to the Markdown that they actually put in there. Right, so this is what we're going to be doing today. We're going to just try to establish a connection, make a query, receive some data, but there is a catch in here. There is a little bit of a catch. According to the specification of a Gemini, it is always protected. It is always encrypted. There is no plain Gemini protocol, like in case of HTTP, right? So there's a HTTP and HTTPS, which is secured HTTPS over TLS and stuff like that. Gemini is always over TLS, always. Which is kind of a pain in the ass if you want to just quickly implement a client, but it is what it is and it isn't what it isn't. So that means the core functionality of the client is going to be implemented by OpenSSL. So we had to deal a little bit with OpenSSL. So it's going to be a little bit of a pain in the ass, but I've got a little bit of lubrication, so I think I'm ready to go. So let's go ahead and see what we can do. So I don't remember, by the way, does Jai come with some sort of OpenSSL bindings and stuff like that? So let's actually open the modules. SSL. All right. We're off to a great start. We don't have a, like OpenSSL or anything. I can try to grab this entire thing, just like SSL. Well, there's something... I suppose there's something in curl. Yeah. There's something in curl, but curl is for HTTP, and we're not using HTTP. We're making our own protocol. I wonder if curl has a Gemini. Wait a second, I didn't think about that. Maybe curl actually Yeah. Bro, that is interesting. I kind of vaguely remember that curl kind of implemented Gemini. Language Geministers. Language Geminister. Is that a thing? Oh yeah, by the way, we recently discovered actually one funny thing on the Jai closed beta. What I tried to do, I tried to grab fuck in the source code. In the source code, and I found two matches for the word fuck in the source code of Jai. The first one is the comment, libclang is such a clusterfuck, and I do not disagree with that statement. I do not disagree. I think this comment is well deserved and it should not be removed from the source code of Jai. I think it's well deserved. But the second one is kind of weird. It is within libcurl DLL. Right, it's within the binary that comes with the Jai compiler, right? So, and like, what the fuck is going on? We can search for fuck, and there is this word, Sony guys fuck pie. In fact, there is a whole dictionary of swear words in this DLL. I think there's something like shit. I don't remember. I think there was a bitch. But there's like a kind of like a few different weird swear words and stuff like that. I'm not sure if some of them are TOS friendly. And apparently, like, you can try to Google this thing. You can, yeah. So Google brought a dictionary contains Sony guys fuck pipe. So, and broadly, GitHub is a compression format, a compression library by Google. Oh yeah, so there's also XML Cog Gang. I forgot about that. There's also XML Cog Gang. XML, yeah. XML Cog Gang. Yo, where's my homies from XML Cog Gang? So yeah, this is a pretty cool library. So 10 out of 10. But I do not approve any hateful shit that may occur in here. But XML Cog Gang, I do approve of XML Cog Gang. So anyway, so I suppose there's no like Gemini even in curl, but they kind of I think curl had like a Gopher. Yeah, it had a Gopher implementation, so not really Gemini but Gopher, and Gopher is kind of other similar kind of protocol, but it's older. It's much older. Gemini is modern one. Everyone is a gangster until XML Cog Gang rolls in. Exactly. XML Cog Gangsters. Anyways. I suppose I'm gonna actually maybe create a folder for our project. So how are we gonna call our project? So there is a very famous Gemini client which is called Lagrange, right? And it's named after a French mathematician. I think it's not really French, it's a French-Italian mathematician. So I think we need to call our client also after a mathematician. Right, so after a mathematician. I was thinking to call him maybe Voronoi, right, after a Ukrainian mathematician. Right, so I think it's a kind of cool idea to do that. So I've been also doing a lot of like Voronoi diagrams and stuff like that, and I believe I do have repos in here. Yeah, so there are some repos that are already called Voronoi for Voronoi diagram and some other things. Yeah, so here I was implementing Voronoi diagrams for different degrees, for different norms, different Euclidean norms and stuff like that. And I also implemented Voronoi diagram for OpenGL on shaders. Right, so I can't just call it, maybe I'm gonna call it Voronoi Browser. Right, Voronoi Browser. So this is how I'm gonna call it, Voronoi Browser. So I'm gonna continue the sort of the theme of mathematicians, right? Lagrange, Voronoi. Makes sense to me. Okay, so let's actually create like a hello world and see how it goes. Right, so we're gonna do it like that. I'm gonna also import a basic. Right, and we're gonna do hello world. Hello world. So /n, and so let's do jai linux main jai. Let's fucking go. And here is the main executable. Look, we've got hello world. Basic, yeah, basic in 2025, right? So imagine programming in jai and all of a sudden basic. 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 So I suppose the first thing we need to do, we need to establish an SSL connection. Right, so how the fuck do we do that? I kind of vaguely remember creating an interesting example on just github.com, specifically for myself. I think I can find something, HTTPS, how to make an HTTPS query. Can I specify like from Rexim or something like that? Make it possible to include, okay, so, but this is not what I wanted. Is there any advanced search? Does anybody know? So there should be some sort of advanced search where I could say the author, or I can search within, you know, a particular author within myself. How can I find my own profile? So here's my own profile, right? So, and when I search within that profile, can I now search within? No, it doesn't search within myself. Oh, you are. Thank you so much. Okay, that's pretty cool. Like, how do you fucking even use that? So I kind of got used to Discord where I just do like things and it auto completes me like different, you know, parameters that it has, like from somebody in specific channel. It's kind of convenient. It's kind of self-documented. This thing is not self-documented. Right. So it's absolutely self-documented. So simple open SSL client and see, this is exactly what I wanted. Thank you so much. Right, and in here we just like establish a connection to a particular website. Oh, and we also have to resolve the name, which is its own pain in the ass in like a low-level C and stuff like that. So it's gonna be fun. Oof. All right, so yeah, I'm gonna actually put that in the description for anyone who's interested. So here we go. I'm actually super glad that I created this simple example like once, so then I can like keep reusing it. Okay, so how do I do le socket? Let me see. Is there any stuff for the networking? Socket, okay. So there is a generated Linux. This file was auto-generated from the following command. So this module is supposed to help with cross-platform socket programs. It would be great if we could convert all the ASFAX values from an enum, and so on and so forth. Okay. Ooh, it's almost like a C3, like a cross-platform layer over sockets. This is actually kind of cool. I kind of liked it. I actually kind of liked it. So can I do connect? Do you have a connecting? You don't have a connecting. You have accept though. Right, so you have accept, but you don't have connect. And I'm disappointed. So you have bind though. All right. So, but maybe this is the stuff that is in here, right? So connect. All right, so this is what we have. Open a connection to socket of D to a peer address and stuff like that. Okay, so that's understandable. Anyway, let's actually go ahead and like import le socket. Import le socket. So yeah, there we go. It seems to be working. So the first thing I need to do, I need to create a socket. All right, so socket. Let's create a socket. This is how we're supposed to be doing all of that. Here is the socket. And we need to do IF, INET. I kind of vaguely remember all of that shit. Holy fuck. So in the socket type, sock, it has to be streaming. So we're doing a streaming socket. A streaming socket. By the way, since it's an enumeration, right? So socket is an enumeration. It's just S32. it is S32, and IF inet is just a constant, and it's part of PF inet, which is just 2. Okay, that is understandable. And by the way, usually this part is empty, right? So you just put 0 in here, and that's it. And here you get a socket. You just get a socket, and here we can do it as of D. And of course, this entire thing may fail, right? And it may fail if fd is less than 0. If fd is less than 0, we probably want to like print an error of some sort, like would not create a socket for whatever reason. We can try to maybe print the reason, but we need to be able to do str error null. Right, so this is what we need to be able, and then we can just do something like exit 0. But not even exit 0, exit 1. Right, exit 1, because we want to indicate that the shed has failed. But str error is a very much POSIX thing, so so it doesn't know about str error. So what we have to do, we have to probably search for the str error. So let me see. Str error, right, so here's the str error. Where is my scheiße? Okay, okay. Ooh. So, are you telling me convert error return from it's from get address info. So get address info is guy. Okay. That's very funny. Okay. So I don't really see str error. Maybe what I need to do, I have to do plus in here. All right, is it going to? No, it's not really plus, but it's more like a star. There's no way to do str error. Is that what you're telling me? Really? In Jai, I can't just call to the POSIX get error value and string and system. Get error value and string. Fascinating, absolutely fascinating. So you also have to specify the description, but why description is a temporary storage or static string. How the fuck do you use that? All right. So let's actually see how you usually use that. So there's a change log. Get error string. Oh, have been moved to system. So let's actually maybe see where the first time they were introduced. I think, oh yeah, it's this one. To give you a somewhat portable way of doing system error codes in strings, OS run command now tells you what command it was trying to run when it's... Okay. That is actually kind of cool. Edit get error string, but then you can also just do that. Right, but it feels like then later they changed some stuff with this thing. They have been moved... Yeah, okay, so let me find the whole thing in here, right? So it's gonna be something like that. Yeah, so, So yeah, I got confused a little bit. I thought this is the arguments, but this is actually return things. Okay, so that's pretty cool. That's pretty cool. I really like that. Now I'm going to go to our main.jai, and I can quite safely just do something like this. So I can do mcg. So error code and description. Might as well just do something like that. Grab both of these things and just assign them in here. Okay, so I don't care about this one. I don't care about this one. Maybe I don't even care about the error code, right? So I kind of care only about the description. Could not create socket, and then I just do description. Is there any way to inline this particular function call? Right. Is there any way to inline? Because obviously I can't inline it. I could try to inline it, but I think it's only going to take the error code. Right, but it's not going to take the description. So I kind of have to have these two separate lines in here. But I mean, it's probably nice, right? It probably makes it a little bit more readable. There's no way to inline it. Yeah, so I can see that. And also, as far as I know, John's opinion on this kind of stuff is that it's better to separate each individual expression into separate statements, so you can read what the program is doing from top to bottom, right? And this is basically his general approach, right? So he doesn't like a lot of nested expressions because they're really weird and they're very difficult to read because you need to read them from inside out, right? So you have to read them with the inside out. And I kind of agree with him on that, right? So this was one of the main problems that I had when I was programming in Haskell, is that it's like a very huge like expressions, and it's really difficult to understand from which order you have to read things, and it's just like, holy fuck. When you program in imperative languages, it's just like a top to bottom. You just like read it top to bottom. Opinionated. It is kind of opinionated, right? So so it is what it is, and it is what it isn't. So we get some subs. Thank you so much, XCardX, for Twitch Prime subscription with the message, ayo, ayo. Welcome, welcome, my friend. How's it going? How's it going? All right, so we made a socket. So maybe we can even print this kind of thing. Created a socket, and we're gonna put this thing in here. So this is FD. So let's go ahead and just build the whole thing. Right, so, and I probably have to even include system, right? So this is a system now, and it seems to be compiling, right? So now I can just do main, created a socket. We created socket 3. Right, so because 0, 1, 2, and then the third one. 0 is a standard input, 1 is a standard output, 2 is a standard error, a socket is 3, right? So that's how it works. So we get a socket. After that, I don't remember, so we have to like kind of connect, right? So what we're doing here, look at that. We're doing this address scheiße, doing this usual address scheiße, and I wonder, like, there is an abstraction for sockets, right? So there is an abstraction for sockets, and the question is there something that simplifies life when you need to resolve names and stuff, right? So if I do something like get address info, do you have anything for that? Doesn't look like it, honestly, right? Doesn't look like convert at a return from it. Yeah, so there is a guy, str error, right? So there's a guy, but nothing really uses this kind of stuff. So you are still on your own, right? You're still on your own when you do these kind of things. Okay, so I'm gonna just maybe copy paste this thing, and I'm gonna start porting things, right? So ADDR info. Let's fucking go. Where is the definition of, yeah, there we go, here it is. So, and in Jai, I can actually do some pro moves, right? Because I have structure literals. I literally have structure literals, which enables me to do something like that. Look at that, look at that, look at that, look at that. I mean, like I can still do that in C, I think. Yeah, I can still kind of do that in C, but I mean, yeah. Let me see. So there's gonna be family is just S32. You have to specify like the same shit but in here as well, right? I think that's what you have to do. You have to specify the same shit, AI protocol, and so on and so forth. I wonder if you have to have these semicolons in here, right? So is it going to compile? Let's actually see. Right, so I'm gonna just compile that. Now you have to convert them to commas. You have to convert them to commas, okay? So, and this one has to be, you know, colon. This one is enumeration as far as I can tell, so that means it has to be a string. And this one, iProto-TCP. Do you have iProto-TCP? Ah, it's just TCP, I suspect. I suspect that it's just TCP. IFNet, and didn't like IFNet, even though I used type mismatch, so expect unknown enum given S64. Are you fucking shitting me, my friend? So address info, just a second. So here's the address info. Family S32. Okay, so that's cool. And AFINet is apparently S64. What do you want from me, honestly? Like, do you want me to cast it to S32? Is that what you want from me? Am I going crazy? I think I'm going crazy. You're supposed to actually not put dot in here. Freaking C damaged my brain, bro. What the hell is XX? XX basically, like, Jai is very strict about primitive types. It simply doesn't allow you to easily convert floats and integers and stuff like that, where it is dangerous. But sometimes it is kind of convenient to automatically convert things. And in that case, you can say, okay, I don't give a shit, just convert it as C would convert it. So it's auto conversion, right? So you know what I mean? You know what I mean? So yeah, basically like that. All right, what else do we have in here? Okay, so that's cool. That's cool. Finally, it works. So we got the hints. And now we have to perform this get address info. Right, let's fucking go. I'm just gonna copy paste C code. So address info. So these are just pointers, right? So these are just pointers. And to define a variable being a pointer, I think we have to do something like that. Yeah, I think we have to do something like that. And let's take a look at this function. All right, so there is a name. Service, right? So we need to have a host and port, and host and port, and host and port, and host and port. So what's going to be the host? Who are we going to be connecting to? So as far as I know, you can access this website through Gemini as well, right? So this is the official website of Gemini protocol. We might as well just use this website in here too. So, and then we need to have a port. So what's the port of Gemini? Does anybody remember? So Gemini documentation, what's the port? Gemini documentation specification for the network protocol, port 1965. All right, so is that a year or something? Okay, so this is the port we're going to be using here. So this is from the specification, straight out of specification, straight out of the specification. So, and then we provide the hints. So this is the hint. This is sort of the connection that we want in here. And here we're going to have a result, I suppose. Every number is a year. Okay, very funny. Nothing happened in 1965, really? I'm not gonna Google that in stream. Anyways, so let's just continue. Because I don't fucking know, maybe something bad happened. So yeah, and in here we do just rec pi and so on and so forth. I wonder if all of that stuff was automatically generated. Yeah, it was automatically generated. This entire module even called generated Linux. And there is a program that generated all of that. Okay, so that's cool. That's cool. Obviously, it is generated when it's called generated Linux. Obviously. What am I even thinking about? Okay, so, and after that, after we got the pointers and stuff like that, we have to start iterating this entire thing. You know what's funny? You know what's funny? So after you're done iterating this entire shaisung, you have to not forget to free the memory allocated by address and stuff like that. But in C, it's kind of like a weird. But in Jai, we have defer. We can always just do defer. Can your C do that? Can your C do that? I don't fucking think so. And by the way, I said multiple times that as soon as Jai comes out, I'm ditching C and I'm programming in Jai primarily. And this is not a joke. Seriously. Like, I mean, C is kind of useful in a sense that it doesn't stay in your way. But apart from that, it's kind of an old, shitty language, and I don't see a good replacement for C yet, except Jai. The only downside of Jai is that it's not publicly available. So as soon as it comes out, like, I don't see reason for myself, at least, to use C. Like, I'm gonna be just like using Jai for everything. C is unditchable, sorry. But I mean, I'm gonna be ditching it only for my projects, right? Obviously, I'm gonna be using C underneath. Right, so that's totally fine. Right, so but when I'm writing my projects, like on top of the existing C code, I'm gonna be just using Jai. Since that also in Go is a fucking toy language with garbage collector. Get the fuck out of here. So, so does it even exist in here? Let me see. Now generate Linux. Yeah, so here it is. Free address. So that should be super easy. And then what we're doing, we're just like, ooh, this one is kind of difficult to iterate because Jai doesn't have a for loop like that. Jai doesn't have a for loop like that. So it's going to be interesting how we're going to be iterating all of that stuff. So that means we kind of have to just do it like this, right? So this is SD, which is going to be just 0. I suppose this is the result of the, what is it called, of the iteration that we found in here. So here's the address and here's our iterator. And now what we do is while address is not equal to null, we keep iterating, but I suppose also we have to do things like this. We have to iterate it manually. All right, so essentially what we're doing here, we just try to connect, we just try to create a socket. So that means I don't need this entire scheisse in here. Okay, and if this failed, I break out of the entire thing, and then I report an error, which is kind of a funny thing, because I could have actually reported an error right here and exit earlier. I don't really know why I decided to actually exit like in here. I think I know why, because I should not forget to free this entire thing. But I mean, if I'm doing exit, I'm probably not freeing it anyway, so who fucking cares? But anyway, right, so let's actually remove all of that stuff, so nobody cares. Then if we manage to connect, we just break out of the loop. If we didn't manage to connect, we just close this entire thing and we continue iterating the whole thing. This is kind of a weird loop, right? This is kind of a weird loop, but it is what it is, and it isn't what it isn't. So furthermore, so that also, we have address. All right, so we have address, and I wonder if we managed to actually successfully connect to this entire thing. Right, so created connection to, and I literally want to just print the address that we've gotten here. Right, so just print the address. It's probably going to be unreadable, but at least we can try. So where is the structure in here? So this is the socket. This is generated Linux. Yeah, here's the address, and we have sock address. Yes, yes, yes. And here is the, like, depending on the family. This is annoying, right? Do you guys know how freaking POSIX library has different addresses for different kind of protocols? Yeah, they kind of employ tagged unions. They employ tagged unions in C. OOP struct. It's not really OOP structs, it's more like a tagged unions. But I mean, tagged unions are kind of a polymorphism. So essentially, here's the tag. Here's the tag. And here is the data, 14 bytes. Some sort of a 14 bytes. What you are expected to do, depending on the family, you cast the pointer to the structure to a different pointer of sock address inet, as far as I know, sock address inet, just in. And these 14 bytes are now port and address. Look now, there is a padding of 8 bytes because the other bytes, how many, 6 bytes I suppose, were taken by the port and address. So yeah, opaque tag data. Yeah, so that's what it is. This is what you expected to do. So that means once I got an address, right, and I kind of know for a fact that this address has a family of IFNet, so I can kind of safely cast this entire thing to sock address in, right, to the pointer of the sock address in. I think I have to do cast. Right, so I have to take an address. By the way, I remember recently, chat, I remember recently, do we have any Jaya beta testers in the chat? There was some buzz in a closed beta server about new cast syntax, and I completely fucking missed that discussion. Everyone was just like saying their opinions and stuff like that. Is there something convenient for this kind of situation when I want to recast, you know, a pointer to a different structure and then get a field for that? I ignored it completely. Yeah, same. But I heard there was like some sort of a convenient syntax. It's only okay. I'm gonna look into the changelog. So I feel like there was something to like very conveniently take a pointer to the structure, recast it to a pointer to a different structure, and then instantly get a field. I think there was something like that. Right. So let me actually see. So I'm gonna go into the changelogs and cast. Updated the description of array casting. Castravaganza. Oh yeah, I remember that. John called it Castravaganza. So for those who doesn't know, apparently in Jai Beta we have different events where we experiment with different syntaxes, and this event was called Castravaganza. Castravaganza, not okay. So 75 awards, the other option. Okay, so I suppose I'm gonna be like grepping for Castravaganza. Yeah, the cast syntax changes from yesterday beta sparked the discussion on Discord, and we moved over the several ways. Okay. So, oh, option 2, yeah, so it's different kind of things. Option 3, I think this is what I'm looking for. Postfix style cast may using keyword, maybe using the keyword cast, maybe not. Here I have implemented a version suggested by beta user that does not use the keyword at all. The simplest case looks like this. Yeah, I was thinking about that. Right, so essentially, so then I can very easily just like get a field. So I'm taking the address and then I'm doing something like this. So then later I can take an address, scene address, like this. Isn't it cool? I wonder if it's going to work. Let's actually find out. All right. So, and as far as I know, from what I kind of vaguely remember from the discussions, like I basically overheard a little bit of the discussions, is that some of the syntax is useful for some situations, and some of the syntax is useful for other situations. So maybe these different kind of cast syntax are going to be there for different situations. God, I hate socket.h. Yeah, I'm saying it's just it is what it is. But I'm hoping that Jai, the mechanisms of Jai, make it sort of like bearable, right? So yeah, we'll see. Anyways, let me try to compile that, and yeah, so this obviously has to be stars, not ampersands, and obviously this kind of stuff doesn't work this way, right? So we have to do it like that. I wonder if it's going to catch this kind of situation, right? Because quite often, here's the thing, quite often as a Jai developer, you're going to be copy-pasting C code into Jai and just porting it. So you're going to have a lot of situations when you have printf and this kind of formats. I wonder if Jai actually catches this kind of situations because it expects you to copy-paste C code. It's going to print S at the end, so the compiler doesn't look into that. Is a shame. That would be actually kind of a cool quality of life thing that would tell you, bro, it looks like you copy-pasted printf C thing. Right, so, and would like suggest you something, and maybe some sort of way to suppress that warning if you really meant S at the end. So yeah, that would be actually kind of cool, but I mean, maybe it's not really priority right now. Could be implemented in the program. So yeah. So, but I mean, the whole checking of the string literal is already a meta program. So it's more about modifying the existing meta program, right? You know what I mean? Yeah. So I could add it as a meta program, but I mean, so it's just extending existing meta program. All right. So we have this kind of stuff. No arrows or anything. Yeah. Might as well just query replace arrow with dot right away. Boom. Okay, what do we have in here? So mismatching level of indirections. You expect me to have this as a port? That doesn't make any fucking sense. Or am I missing something? I think what is going on in here is that port has to be a string all of a sudden. Are you serious? Port is a string? So service. I gotta check that, seriously. Like, I kind of vaguely remember that. So service, so given node and service which identify the net service, service sets the port in each return address structure. So yeah, depending on the family, it just like means different thing, and that's why this thing has to be a string. Okay. We're gonna get there. Don't worry. It's just like usually network programming starts up slow, right? It starts up slow, but then as you kind of establish connections and stuff like that, it's getting faster. So, all right. So, and then here we do Oh, and this one is really interesting because for the get address info, you're supposed to be using their own thing, right? So you're supposed to be convert error return from get to, okay. So, and get address info, right? So man, get address info, where is that? The return thingy, the return value, return 0 if succeeded, or one of the following non-zero errors. Non-zero errors. All right, so what we can do in here, we can say guy error, right? So guy error, or maybe just like guy. And if guy not equal that, we use the guy str error like so, and we just do this. Guy. So could not get address, blah blah blah, blah blah blah, blah blah blah. Okay, that's cool. We're almost there. So then we do connect. It doesn't like connect because trying to fit 64-bit. All right, so I think this thing has to be S32. S32. Close. Okay, so now we do close and declared identifier close, which is kind of weird. Like, why don't you have close? Is it not part of the module? Is it not part of the other things? Looks like it's part of the POSIX. And we probably have to import POSIX stuff. So let me actually see. So this is going to be POSIX. I wonder if we'll have to do POSIX. Maybe it's capital POSIX. Isn't that poggers? We managed to compile this shit. Holy fuck. Right, so the complexity of this entire thing comes from the fact that we're trying to connect to a name. So we have to do a little bit of a gymnastics to resolve that name, right? So because all of that stuff will probably result in a DNS query. I suppose get address info does perform a DNS query, right? So, and it just gives you a possible resolutions for the specific name and port. Right, we have to iterate through all of them, and we have to try to connect through all of them, and we have to just accept the first thing that is connectable and call that a connection. Right, that's how you do networking in POSIX, I suppose. So yeah, we've got some subs. Thank you so much, Twarog, for Twitch Prime. Thank you. Really appreciate that. Really fucking appreciate that, mate. All right, so let's actually try to run the thing. I'll connect it to two. Whatever the fuck that means. 2. But we connected nonetheless. Look at that. So all of that shit, right? So because we did all of these error checks and stuff like that, none of these things errored out, and that's very important. None of them errored out, and we reached this specific place. So that means we kind of successfully connected, which is cool. So we didn't decode the address properly, right? So let's actually quickly try to do that. So scene address generate Linux, right? So it's an in address, and in address, so is S address, and this is just a U32. We have to kind of, I mean, we have to view it as, you know, every single octet, right? So we need to view every single octet. And to be fair, if you take a look at the hex of 2, right? So if you just take 2 and you take a look at the hex of it, it doesn't look like a proper address to me, like at all. So that is a little bit bizarre. Maybe we connect it to some bogus amogus thing. Obviously, an in address is S address just a common name. Yeah, probably. Yeah. So, and as far as I know, there was like ways to convert them to readable names. I net address. I do not quite remember, but what we can do, we can try to grep man pages, right? So this is one of the things I started to do recently, just like literally grep user share man, right? And just like look at different things you have in here. So there is a SOC address. Right, SOC address. Maybe even IP. So here is the cool page, IP7, right? So I can do IP7, right? And there we go. So, and here I can do different addresses. INET, in address. So scene address. INET. Does anybody remember? So there was a INET N to A or something. Yeah, INET N to A to N, N to A. This one. Yeah, it's kind of easy to like forget. All right. So and in here, so this is probably what we need. We need, I think. Ooh, this one is actually kind of bad, right? So it accepts into which it's going to save this entire stuff, which is not great in my opinion. This is not particularly safe. Converts the internet address from IP numbers to dots notation into binary form. So let's go to here. So here it is, convert internet host address from numbers and dots notation in CP into no, it's actually INET N to A, N to P. Okay. Convert an address in a binary network format for the interface type IF in a buffer starting at CP to represent from, and it accepts the, okay, so this is actually kind of perfect. This is actually what we need in here. Right, so let's go ahead and try to maybe do the convertione. So this one is going to be obviously IF INET. So then we're gonna have some sort of a so CP represent from interface in a buffer. I need to, yeah, so this is what I need some examples on how you use this shit. So this is a source. I just give a pointer to that address, I suppose, right? So I just give a pointer. So I'm providing this stuff. This is the pointer. And the buffer, I need to allocate a good enough buffer. Right, so it's obviously going to be some sort of a thing in here. So the octet in decimal takes 3 digits, right? And we have 4 of them, and then we have 3 dots, something like that. Right, so this is obviously, it's 15, if I'm not mistaken, right? So this is 15. We might as well just give it 32, you know, characters in here, or maybe U8, just something like that. So, and then I just give a pointer to this entire thing, right? So this is probably how I do that. And len, is that the length of this thing? Is that the length of this thing? Maybe it is, right? I don't really know. So this is kind of like a weird stuff. So destination, well, it's called size in here, which is, well, I mean, according to this documentation, the destination is the size of this thing, which is perfect. And I suppose I can do some buffer like count. Can I have like a buffer data pointer, right? So maybe I can. So, and this entire thing returns something interesting. Returns a non-null pointer to DST. Null is returned if there was an error with error no set indicate. Okay. Let's just go ahead and straight up print buff, because I'm kind of curious what the fuck is it going to display in this specific case. All right, so it didn't fail, which is great, and that's pretty cool. So it printed something. I need to convert it to a string. So this is going to be a string. All right, so data is a buffer data, and account, what's going to be count? Just a cast? You think cast is going to do it? So we can try to do that. So cast string. I feel like it's not going to work, but we can try to do that. I'm kind of doing a mistake in here. Okay. How is that a correct address? What the fuck is this address? C style strlen. Yeah. What the fuck is this address? Does anybody know? Did we connect to a correct thing even? It's a Gemini. I feel like it's some sort of a bullshit. Is more complicated than that. There are also addresses that look like. I mean, it's a IP, isn't it? It's a IPv6, isn't it? But it's also IPv4. So that's kind of bizarre. Anyways, so all right. Maybe it's just like a kind of a different thing. So let's go ahead. Oh, by the way, I never really checked that this thing was kind of -1. So maybe it didn't succeed actually. This could have been a thing that this entire shit didn't succeed. If this is a failure, right? If this is a failure, yeah. Maybe we can say could not find suitable address for this where we have a host and port. All right, so no, it's actually fine. Look at that. So it's actually fine, and it thinks that it connected to here. So I don't really know what's up with that. Maybe I'm just like doing something in here incorrectly. Maybe I'm just using incorrect function or incorrect field or whatever. So I'm gonna just assume that we successfully connected to this entire thing. So we need to make a small break, right? So I need to make a cup of tea, and after the cup of tea, we're gonna try to maybe establish an SSL connection, right? So we'll have to link with open. It really fucking bothers me. What's up with the address? Right, I would expect it to be an address of like maybe resolved IP address of some sort, but it's like, what is it, 200? Is there something about that? Like, it's just, it really fucking bothers me. Because I may proceed doing OpenSSL thing, but then it's not going to work because I connected incorrectly or something. So let me see, IP address 2000. Yeah, okay, so what the fuck is that? Is there anything about such address? Is it going to show my address? Fuck. I should be careful with this shit, chat. I should be careful. Verifying your request. Yeah, it doesn't even show me anything. Free 2000. Google is cooked. Google is absolutely fucking useless. It is absolutely fucking useless. And I have a hypothesis that they're doing that on purpose. They're doing that fucking on purpose, so they use their shitty Gemini thing. Right. So yeah, it's kind of weird. The IP is already at the bottom of the screen. Yeah. Okay, so does anybody know what is a 2000? Like in the chat at least. So they're doing that for the advertisers. Okay, so nobody knows, right? So the answer is nobody knows. We can ask like a llama or something at least. It's kind of weird. Oh my god, it's going to ask me a bunch of shitty questions. Go away. Okay. Do you know anything about IP? Okay. Of private IP addresses, specifically block which is not routable to the internet. Okay. So in the context of IPv4, block is one of the private addresses spaces defined by RFC. Aha. All right. So do you have an RFC browser? Okay. So, and 1918. Okay. So address location, allocation for private internets. There's nothing about that. Fucking hallucinated yet again. So means the IP addresses within the range including are intended for use in private networks. Are they intended? I don't think so. I actually don't think so. That they're intended for the, like, where are they? It's a range belongs to Oracle. My friend says it's a range. It's a range that belongs to Oracle. They're gonna replace us all! Holy fucking shit! Fuck you. So anyway, friend is correct. It's just, it's like always agrees with you. This motherfucker just always agrees with you. It's like it's useless. Anyways, so maybe. Oh wait, maybe it does belong. We can try to do maybe who is. So let me see. Gemini protocol. Wait, can I do host? Nah, it resolves to a completely different shit, so I don't know. And before AI is correct. Maybe it is correct, I don't fucking know. Anyway, I need to make a small break, make a cup of tea, and after that we're gonna just do our... We're motherfucking back! So I've got an idea. What if what we got is actually not IPv4 family, but IPv6 family. I wonder how we can actually check that. So here we can go ahead and take the like a family address, and we can simply print it like that. So family, it's gonna be like this. I'm gonna put it in here, and let's just go and try to rebuild the whole thing, and it doesn't even build properly. I wonder why. So what's up with that? Undeclared buffer. What did I remove? Yeah, so I actually accidentally removed this entire thing. So let's do it one more time. Family percent. I always said s, but there's no s after the percent. And this is address. What was the AI family? AI family, like this. All right, so family is 2, which is inet, which is actually inet, so I don't think it was that much of a problem. So I have inet, and there's no inet 6, honestly. Well, I mean, there is inet, and if you take a look at the pair of inet 6, it's actually 10. So yeah, it is not inet, so it is something else, and it is really, really weird to me. Like, I don't really know. What if I try to put, I don't know, Google? All right, so what if I put Google in here? You can't, okay, so you can't connect. What if I put 80 in here? It's still, it always returns 2000. Like, it always does that. So I'm doing something incorrectly. I'm definitely doing something incorrectly. AI address, and it's also what the fuck is AI address though? I need to take a look. AI address, yeah, so address info, socket address. I think I'm an idiot. I think I'm just like doing the wrong thing. I was casting like a completely, oh my god, this is not what I should be casting. So it's an address info and okay, so the socket address, if I take a look at the socket address is yeah, I should be casting actually socket address. All right, so I take this thing, sock address in, or whatever the fuck it is. So let me go back. AI address. Okay, so AI address, then I cast it to that, and that should be the thing. All right, so now if I try to run that, it didn't easily work for me because I have to take a pointer to that. And that looks like a, yeah, okay, so that looks like an address. What is this address? So let me take a look at who is of this address. I hope it's not my address though. Oh, it's a Google's address. Okay, this is a Google's address. Perfect. Okay, so we found an error. I'm actually super happy. I'm actually super happy that we found an error. Right, so let's go back to Gemini 1965. So yeah, I'm gonna grab this entire host, and now we can try to take a look at that. This looks like the address of the Gemini. Yeah, so that's the thing that I see is so in Whois. That's the thing I saw in here. This is perfect. Okay, this is perfect. So the question is now, how can I convert to C string? C string. There was some sort of a module to do, I think, C string. To C string. Is there some from C string? Just C string. Okay, so maybe it is to string. To string, to string. Ooh. Wait, really? There is literally to string. I didn't expect. Okay, so that means I can actually do the following thing. I can grab this entire stuff, right? So this entire stuff, and say to string. I think I can do that. So because it's actually the sock address, so I can do to string on that one, and that's it. Kinda, almost. Why it didn't work for me? So because it's a socket, and it has to be. Am I going crazy? I have to dereference this entire thing. Is that how we do dereferencing? Bro. So what you don't like? What you don't like? Because the scene address is it's annoying. Different kind of pointers and stuff like that. Do I not? Does it have all? Okay, we figured that. We finally figured that. So I just forgot that Jai also has auto dereferencing, right? So if you have a function that accepts a value but you pass in a pointer, it will also auto dereferencing. That's an old auto dereference. The new one is dot star. Okay, I'll keep that in mind. All right. So whatever. So but there's also auto dereferencing. Okay. So that's pretty cool. Finally, we made a connection. We made a correct connection. So we now can start working with OpenSSL. The question is, how the fuck do we do that? Is there like a Jai OpenSSL anywhere? Simple OpenSSL, awesome Jai. Okay, so there's an awesome Jai OpenSSL. All right, so we're gonna assume that nobody done any OpenSSL stuff at all, right? So nobody even tried. Okay, so do I have OpenSSL anywhere in here installed? I do have it. Okay, so that's pretty cool. What do you usually include in this thing? So it's OpenSSL, just ssl.h. All right, so warning, do not edit, generated by makefile. Okay, fair enough. So I think the time has come. So there's somebody, HTTP server, somebody made an HTTP server. That's actually kind of cool. Thank you so much. It doesn't open. Is it so? Why you just decided to DDoS me? You gave me a huge ass file, you decided to DDoS me. I'll remember that. I'm joking. Alright, so broadly. It doesn't even have XML code gang. Disappointed. Fucking disappointed. No XML code gang. Sadge. Truly Sadge. Alright, so, and it has like a, it's not even generated, it's like a very basic thing. And it's also a server. Right, so it probably doesn't have the client part. The client part that we need. So, but we may use some of this stuff. It just calls SSL, right? Why? Oh my god, GitHub, so bad. And it then calls to OpenSSL, which is a foreign thing, foreign libSSL, and it's a system libSSL library, a libcrypto. Okay, I think I'm gonna start just like simply stealing some of this stuff. Right, so I'm going to... It was actually not that big, by the way. Speaking of, it wasn't that big. I don't know why GitHub was stalling to load this file. Right, so yeah, so I'm going to actually take this thing and put it in description as a reference. Right, so as a reference. It's pretty old, but serve as a starting, yeah. So we can just like use it as a reference. I don't plan to just straight up copy paste it, but we're definitely going to be using it as a reference. So modules, let's create some modules, and in here we're going to have OpenSSL. Right, so that's what we have. And I suppose when you do module.jai, you essentially have, like, when you load this module, you're going to be loading this file. Right, and one of the libraries that we're going to have in here is a libSSL and libcrypto. We want to be able to link with these two things. All right, so if I now just import OpenSSL, obviously it's not going to work. I think I want to capitalize it like this, right? So because that's usually how OpenSSL is capitalized. So let's do it like that, OpenSSL. So if I just try to build it, it is not going to build. It didn't build, right? Does it automatically searches in... Really? It automatically searches in modules. I don't have to have a first.jai. It's just like, this is automatic now, right? If I try to just change this name and then, oh my God, I don't, this is cool. So there's a convention now. It searches for local folder. Okay, this is perfect, right? So because I remember that you had to add this thing to the search path and stuff like that. So is that a recent thing? Maybe it was always there, but I just didn't know that. Like I had to like do it manually. That's how game developers do things. I see. Okay, so there is some sort of a convention in here, which is actually kind of cool. I approve of this convention. This is a very cool convenzione. All right, so where's the simple thing in here? So after we establish the connection, one of the things we have to do OpenSSL add all algorithms. Right. So does this thing have... Yes, it does. Right, so add all algorithms. And what's funny is that, as far as I know, there is no such symbol in the OpenSSL library. There's no such symbol. I think it is a macro. Right, if you go into, I think it's a user include OpenSSL, and just like grep for this entire thing, just grep for it, it is a macro. And this is an annoying thing about OpenSSL library. I worked with OpenSSL library a little bit. Some of the symbols are macros, some of the symbols are functions, right? So, and like it's very annoying. It's very annoying sometimes. And it even refers to another macro. I think this stuff is also another macro. Yeah, it is another macro. And then internally it calls to OpenSSL init crypto. And I think init crypto is also a macro. No, it isn't a macro. Right, well, I mean, yeah, so this is the only like a function in here that that we call in here. But yeah, so just like initialize all of these things and stuff like that. And this is why they have this separate function. Could have been a macro, by the way, just to maintain the consistency with the C code. We could have made it a macro. So module.jai, so this is modules. One of the things we can do is expand. Is that how we do that? Right, so expand and this becomes a macro. Right, I think that's how it's done. So in here we can just do the following thing, main.jai. Main.jai. So we're gonna put it in here. So if I try to build the whole thing, so it doesn't have OpenSSL init settings. What is init settings? It is an empty structure. Maybe, okay, so here's the thing that I'm thinking. Maybe I should just try to do the bindings generator on this thing, right? Because the person who created this bindings, they obviously tried to do it manually, but Jai is coming with its own bindings generator. Look at that. So, and it's kind of interesting. I don't remember how to use it. So on Linux, all right, we do something. I used it once. That's the thing. I kind of used it once, but I already forgot how to do that. It's a bit convoluted to use. Yeah, this is one of the things I remember. Bogus Amogus. Bogus Amogus. Do I want to try to do that? I feel like I don't want to try to do that because I don't really need that many functions anyway, and I feel like I'm gonna sink a lot of time into just like trying to figure out how to use this entire thing. So I think I'm not going to do that right now, but maybe later. Maybe later, like generate bindings for the entirety of OpenSSL and put it somewhere on GitHub would have been beneficial for the community, right? So, but right now I don't want to do that. Check out the first energy. Yeah. So I just don't want to sink the time into that, right? I want to have some minimal working example right now. Like I know that it's cool. Like I already tried it. Like guys, I'm gonna do that. But let's not sink time into that because we don't know for how long I'm gonna be messing with this entire thing. Right. So let's go ahead and just like do that. Okay. So now we need all of these things like OpenSSL. We need all ciphers and stuff like that. So we're just gonna do the thing where we go into the compilation errors and just fixing them, just copy pasting the stuff that needs to be copy pasted, and there you go. All right. So now the next thing we have to do, we have to load error strings. It's like, why OpenSSL is like that? Why loading strings, like error strings, is a separate operation? I never understood that. It's just like, it's like you need to work in such like weird embedded environments where to preserve the space, you kind of load in error strings separately. This is a really weird use case. What's the use case the developers of OpenSSL had in mind when they introduced this kind of stuff? It's just like, what is that even? Some embedded compatibility bullshit, and it's imposed on everyone. Yeah, so why? It's just like, it's bizarre. And what's funny is that like the encryption algorithms are literally functions that take a sequence of bytes and give you another sequence of bytes, aren't they? Well, I mean, okay, so there's a little bit of a protocol stuff going on, handshakes and stuff like that, but does it really have to be this complicated? Maybe I don't know what I'm talking about, but anyways, like sometimes like I wonder, why is it complicated? Is it really necessary? It's just like you really have to ask this kind of question sometimes. Is it necessary? So we already have init settings, right? So this is that. Okay. So everything seems to be working. Everything seems to be working. So the next thing we need to do, we need to create the context. Right. So TLS client methods. What the fuck is a TLS client method? Do I have it anywhere? I actually don't. Right, and that's kind of the problem in here, TLS client method. So what I have to do now, I have to go and in OpenSSL search for these functions specifically in here. Right. So for people, like at the beginning of the stream, somebody asked me like how to get into Jai Beta. You really want to get into Jai Beta if you're willing to do this kind of shit. So are you willing to actually like Google around different weird old examples and also original libraries to stitch things together to make your thing work? Right, because you need to be experienced enough to be not afraid to do these kind of things. Right. It's a language for very much experienced developers, and it's a language for experienced developers that is not really finished. Right, it has a lot of expectations from you. So are you really sure you want to be, you know, testing this kind of stuff? So be careful, be careful. It's kind of fun, right? It's kind of fun, but at the same time, you know what I mean? You know what I mean? So this is the thing we need to have in here. All right. So I'm going to just do module, right? So So Jai is -69 user-friendly. It is very much user-friendly, but it's like Unix, right? So it's very picky about its friends, right? So it's just like, so it's very friendly towards programmers. Speaking of imposter syndrome, so anyways, so for so get some subs, by the way. Let's acknowledge some subs. Thank you so much, Fidot Compot, for Twitch Prime with a message. Good evening. Dobry вечер. Dobry вечер. Our const. So did it say const? Yeah. So it's almost like uwo. Uwo. What the fuck is the SSL method? Does anybody know? I think I need to do SSL method search. I swear to God, this is some sort of a struct. Yeah, it is a struct, and it's probably opaque struct. We can do a trick that we already did in here, which is essentially, fuck you, I don't care about your struct, let's make it opaque. Notice how Jai allows you to have empty structs. Can your language do that? Like, lots of languages actually don't allow you to do that. Jai, I wonder, like, what if I try to... What's the size of this structure, actually? Just a second. So that's kind of interesting. Like, how the fuck does it work? Okay, so context, we also need to have a context. Let's actually comment it out, right? So because I want to test it out. So how do you take the size of the thing? I think it is a size of... oh my god. Yeah, so it is size of. So now it's a J and print size of SSL method. Size of SSL method, and it's actually exit with 69. Let's fucking go. And boom, 0. It is literally 0. It is literally 0. Like, the thing is, lots of system languages don't allow you or even discourage you to have structs with 0 size. Jai is totally fine, it doesn't even throw a warning. So I wonder if I try to create an array of these things, right? So if I create like a 69 of SSL methods, how is it going to even work? Okay, it is totally fine. And what's the size of access in here? Okay, so here we need a type, a constant type, but we got here we need a constant type, but we got an expression of type override. So what if I put this kind of thing? So what's the size of this type then? It is 0. So, which also implies that if I try to index this entire thing, what if I... what kind of code does it generate? Yeah, I could have done a type of, thank you so much. Right, because if you have a type of size 0 and you make an array of that type, the size of the array is 0, it's unindexable. Though not really, is it? Yeah, 69 multiplied by 0. So you have an index, right? You have an index, and essentially you multiply it by the size, which is 0, and you add it to the base, to the data pointer. So you still have this pointer, then you dereference this thing. But since it's... what does it generate? Like, I'm actually really curious. Look, dump on the procedure to look at the bytecodes. I don't know how to use dump. Let me see. Dump. Dump directive. Okay, improve the dump directive output, but how do you use it? All right, so we probably want to do foo. Right, so we want to move this thing in here. Dump. Is that how we do that? So then, all right. Oh, that's a lot of code. All right, so no dominating. What the fuck is this? What the fuck is dominating? Can we just reduce the amount of shit in here? So integer, so it calls to something like this. Type of. Well, I mean, that's not particularly great thing to do anyway. Yeah, I'm not sure what exactly want to return in here because I want to try to index this thing. Only bottoming the yeah, bottoming is like fucking. Okay, make it return SSL. Yeah, probably that's a good idea. Access 10. All right. So what do we have in here? Binop. So stack and plus 0. We're loading a pointer to the stack into this register. Then binop. What the fuck is binop? And then return. What am I even looking at? What the fuck is binop? Okay, so Leo, we loading the effective address into v2. So in v2 we have a pointer to the stack, to the top of the stack. Then binop. Binary op, which one? It's a too abstract of a name. Like which binary operation? Yeah, so that's exactly plus 0. So it returns. What does it even return? That's kind of weird. So I don't know. That's kind of weird. But anyway, so I guess it works somehow. Right? I guess it works somehow. Okay, guys. So let's actually continue. We already have this thing, and we need to have SSL context new. So maybe this library is going. Yeah. So this library does in fact have that. So and we can actually steal that. So yes. What do we have in here? So we already have this stub, and that's about it. So that should be actually it. Let's fucking go, and here we are going to just have like this. Okay, that's pretty cool. It did a connection. So look how it takes a little bit of time to actually perform the connection. Well, it's actually rather fast now, but I mean, yeah, so it's a significant time. So it's doing things. It's definitely doing things. And furthermore, when it may fail, actually, it may fail. And why do I assume that the error is going to be an error no? That is kind of bizarre of me, isn't it? I think that's kind of bizarre of me. But in any case, we can do if ctx equal to null. Right, so we should say that we couldn't create the SSL context. All right, so print could not create SSL context. For whatever reason, it would be kind of nice to know the reason. And I wonder if there is something about that. So, oh, I saw something. SSL print errors. The thing is, oh, there's a lot of things like that in here. So there's a lot of wrappers in here that automate all of that stuff, but we're not going to be using them, right? So because I want to understand what exactly is going on. This one is cool, and there is a weird thing about OpenSSL is that it has like a stack of errors or something like that, and you have to kind of unwind that stack, right? So look what is going on in here. So while true, we do error get error, and then we're printing it, and then we're repeating until we exhaust the stack of errors. Because essentially, I think it was designed so you can perform a bunch of operations without checking their errors, and then you can check all of this error at once because it kind of logs the errors. So it looked to me like it was taking the address of the variable on the stack, the alias stack plus 0, and then the binop was the array index of set, but since the size is 0, it just added 0. Yeah. It's bizarre. It's kind of weird. What's interesting is that okay, you can get an address to this empty array, and the address is going to be the base of the array. But you're not gonna dereference and write or read anything from that array because the struct doesn't have fields. Maybe it doesn't matter. Right? You can't read this thing anyway. You try to get a field, but there's no fields. You physically cannot do anything. So that's probably why it's fine. I was thinking why it is fine. It is fine because this pointer is useless to you. On the level of the language constructs, you have no way of reading or writing into that. Maybe you can use it to get a pointer to the top of the stack. Probably. Oh, this is actually kind of cool. This is actually kind of cool. But I mean, Jai has its own pretty cool assembly, so maybe I don't even need to resort to these kind of weird tricks. So, what happens when you try to dereference it, though? Nothing. Right, look, you have a pointer to an empty struct. You try to dereference it, but you can only meaningfully dereference it if you have fields. See what I mean? You can't meaningfully dereference a struct if it doesn't have a field. You can't. Just that. So anyway, let me now try to see. Cast to a pointer. Maybe cast to a different pointer type. So you cast it to a different pointer type, and only then you can already kind of meaningfully dereference it. But when you actually pawning the types, you're already doing something fishy, right? So that means it's all on you already. It's all on you. Now, what I was doing, I kind of forgot. I wanted to steal this function because I think it's kind of useful. I'm gonna steal this function a little bit. Right. I want to reindent it a little bit like that. So what does it do? We just do something like this. All right, so get error. Why is it 1? Why is it not true? Bro, we have booleans. This is a proper language. So error from str. And I think this is kind of useful in a modern Jai because it's like a two. What was the function? So you have a C string to convert it to not a C string. I think you just do toString, right? So you don't need any of that stuff because obviously what it's trying to do in here, right? So we're trying to convert it from C to other things. So we get some subs. Thank you so much, Y Software, for tier 1 with the message heart to you as well. Thank you so much. What was that? I think it was toString. Right. So I think it was toString. Let me double check. Jai mods rn toString like this. So sister, was it sister? To C string. Yeah, so nah, it's not from C string. What was that? What was the function from string? So there was a function for that. Chat, you were actually backseating me on that, but I can't find it. Is it toString? Nobody knows. So I think that's it. Yeah, so that's it. Get fucking damn it. Like, everybody backseats me when I don't need it, but when I need it, everyone is silent. Like, is that a thing? Is that a function? I think that's it. I think that's the function. Okay. But I mean, it's a wrong one. System string something. I think that's this one. Allocates memory though. Allocates the... I knew you'd instantly find it. What's the function though? Is it like a C-style link or what's... Okay, whatever. I'm wasting time, so I'm going to just like leave it as it is then. We're not going to be using any other thing, so only this one. Does it... yeah. There is a C-style, you don't need it. Well, I mean... I swear to God, I remember there was this function in the standard library. Like there was literally this in the standard library, wasn't it? And I think I'm looking at it right now. So this is the opposite one. This one accepts length. There is a multiple overloads. Yeah, this is annoying part of Jai. It's just like, where is it? So C string. Oh, it's an. Okay, found it. It's this is one. So two string. Okay. We figured it out. All right. So that means I can just do two string. Finally. So this is what we're gonna have, and I suppose now I can go to main.jai and simply do that, and just like exit with one. Exit with one. All right, so we're gonna just do that. Right, so and there's no error, get error. Okay, get error. So we're gonna bring that one in here. Okay, so print. So what is it like? So it wants to have basic. Wants to have basic error string. So maybe I need to copy paste. Well, I mean, why does it take so much fucking time to just open a raw version of this file? Freaking GitHub! Can you just hire like a proper engineers already, not web devs? Anyways, so yeah. All right, where is the function? Okay, so here it is. There we go. Cool. That's cool. So, and also it didn't fail when we tried to create a context. Perfect. So it didn't fail. So now we can create a new SSL connection. So we can do SSL new. Right. So now we can do this kind of stuff. And by the way, we can now also use defer in here. Look at that. So we don't have to put all of that stuff at the bottom. We don't have to put any of that stuff at the bottom. We can simply now, when we created the context successfully, we can just do defer on this one. Then when we created the SSL connection successfully, so here we we don't even check this entire thing, but I think we should. I think one of the things we should do in here is if SSL is equal to null, we just do SSL print errors, exit one. I feel like exit one does not do defers. I think it doesn't do defers, like it just basically calls the exit syscall, but maybe that's fine. Maybe that's totally fine. But in any case, so we'll then have to do this thing. So set shutdown, yeah, so this has to be free. So this simply allocates this thing, right, and this frees it. Okay. So after that we have to do the connection. So we also set in the file descriptor. So here is the new SSL socket. We're setting the file descriptor. Then we're trying to connect, doing SSL connect. Even though we're already kind of connected the socket, now we need to do connect through the SSL, which I suppose is going to do handshakes and stuff like that. Right, so SSL print errors. We're just printing an errors. And after that, we can finally perform the reads and writes and stuff like that after we connect it. So here we're doing the shutdown, which is kind of weird. Why we first set the shutdown and then performing the shutdown? That's kind of weird. But I mean, I guess that's how we do that nonetheless. I wonder if I can just do this kind of stuff like this. Right. And then, yeah, that's about it. We just need to write the query. We just need to write the query. But what kind of query do we write for the Gemini protocol? That's a good question. We'll see, we'll see. So if I take a look at the documentation, so where is the spec? Formal spec of the network protocol. I need some example of a query. Okay, so here is the URL, right? Here is the URL, but I want to see an example. BNF is kind of cool when you know roughly how the query looks like, but I don't even know roughly how it looks. Okay, so here is the cool thing. So this example here requires user input, which is, well, I mean, it's not really what I want. So open connection, send a link, literal URL, and then the server will respond with something. That is kind of based, if you think about it. This is how you do a query. Wait, this is based. What the fuck? Opens connection, URL, you get a shit back. So yeah, so okay, we can try to do that. And I suppose in here, the URL that we're doing is going to be something like this. So it's going to be Gemini. Yeah. This is going to be our URL. Okay, cool. So obviously this is not going to compile. So we need to actually have bindings for all of these functions and stuff like that. So let's actually go through all of these things. So we need to free the context. Right, so yeah, we already, is that the same? Yeah, so this is the same thing. So we're freeing, so there's no context free. You know what, somebody said in the chat, like, why freeing the memory? Yeah, so let's actually not do that for now, right? So I don't want to spend time on this kind of stuff right now. Maybe we can do that a little bit later. SSL new, there's no SSL new, so let's actually grab SSL new. So here is the SSL new, so here it is. And we, oh, so there is a SSL free, am I an idiot? Yeah, probably. But anyway, so here's that, SSL new, SSL free. So it means we can enable at least that. All right, so this is not null. Set FD, okay. Do we have set FD? Here it is, set FD. That's pretty cool. Yeah, so we're just setting the file descriptor of underlying socket for this thing. SSL connect, and since this is a server thing, as I already said, like we don't have some of the functions in here, right? So because this is a client part. So what we can do in here, we can yet again just grab this thing, find this thing in here, and just bring it there. Module SSL connect. So here we just accept SSL pointer and return S32, but it's a foreign thing. So yeah, it has to be like this, libSSL. All right. So now we're gonna go to here and it compiles. So this is very cool. This is very cool. What we can do now, we can send some information to the client. How do we send that information to the client? We perform, right, so here's the request. Well, I mean, our request is URL, literally. SSL write, give me your SSL write. So we're gonna actually have both SSL write and read. So we're gonna put it in here, and let's do the write. Let's do the write. So here's SSL. The buffer is going to be URL and URL count, right? So we can do something like a data or count. And if this entire thing didn't succeed, we're gonna just, I suppose, print the error, but we don't even care in here, right? So maybe let's maybe don't care. So after that, we need to have some sort of a buffer. Okay, so let's actually let's allocate the buffer, right? So this is going to be you know, just a kilobyte of bytes, right? So this is a kilobyte of bytes. Then we perform the read, and we just continuously read the buffer and printing that buffer into the standard output. So here I can do data count, right? So this is what I've got, and I can even make it something like this. So, and while n is greater than 0, we're just printing this whole thing. Might as well just print it like that. So since it's a buffer, I can turn it into a string, right? So I can always do something like string as data is a buffer data, but the count is n, right? And then we just print that as. So, and then we repeat the whole thing. So, all right. So we just like read it by chunks and printing each individual chunk, right? So printing each individual chunk. So I think I have to provide like a /r. I think it's waiting for the new, yeah, CRL error. Okay, so that's understandable. So we wrote this thing, so then we have to write, let's make it a request. Let's actually make it a request. Request /r/n. I'm pretty sure it was waiting for /r/n. And this one is going to be request. Okay. We get a response. So that's the whole point of Gemini. You can implement a simple client in roughly 2 hours. Roughly 2 hours it took us to implement a simple. This is a simple client basically, because now there is a bunch of links in here, I think. So is there other Gemini links? I'm pretty sure there's other Gemini links. Gemini. There should be some other. Oh yeah. So here is a Gemini link. Here is a Gemini link. So essentially you have to take the base link, append to this thing, and then continue browsing. So you can already do a basic browsing like this. Okay, we got the next one. Here is a bunch of other links. Right, so here's the news. Right, so I can take this document. So I can take this document and query that specific document. Like I don't even have to have an interface, command line interface. I can just like modify the code directly and get the data. So that's kind of the whole point of Gemini, is to be this very distilled basic version of the web, the original idea of the web, of the interconnected documents. Right, so, and if you want a fancier client, well, you can work on a fancier client. So it's kind of cool that this client doesn't even have command line interface, and to go to the link we have to modify the source code. That's the whole point. Isn't that cool? Isn't that cool? That's so cool. Right, so we can actually go and just like maybe start accepting the URL through the command line. Right, and there you go, you have a basic client. So it's kind of a suckless, but it's also kind of like a apocalyptic style tech, right, where you stuck with the laptop, but you don't have the client for the web, so you just like, you know, sitting in the basement and quickly writing up your own client and then just using it to gain more information, gain more software, and kind of bootstrapping yourself. Right, so because for the actual web you need like a full-blown browser and shit like that, but here you can just like write up your own client. But granted, you need to have an open SSL library, but still. Implementing Gemini client over a 60 baud network post-nuclear launch. Yeah, exactly. That's a cool idea for a game. Yeah, that's a pretty cool idea for a game where like you can connect to the network. Right, when you have to write the first client, and then through that network, through that web, you gain more documentation and more software to access more different things and stuff like that. And eventually you hacking into some sort of like a data center of the AI that, you know, took over the humanity or something like that, and blew up a nuclear plant. So to destroy that AI or something like that. So that's, there's a hacknet. I don't know, is that the game? Post-AGI programming games, yeah, something like that. There was an old Flyer game that did that. That's actually kind of cool. That's actually kind of cool. So yeah. So let's go ahead and just like maybe make this command line argument super quick. How do you do command line arguments in Jam? I don't quite remember. So I think it was a huge ass name, kind of similar to the get error. Right. So what was that? Get, yeah, kind of similar to this one. So yeah, exactly. Get command line arguments. I remember it being a huge ass name like that. I wonder why John decided to call it like that. But I mean, John likes these overly descriptive names. And to be fair, for this kind of stuff, you don't really use that function very often anyway, so it's not gonna look too ugly in your source code. So yeah, and what you get in here, I suppose, is literally just an array. You get a slice. You get a slice. All right, that's perfect. So I'm gonna do args and something like that. Something like that. So we're gonna just print this entire thing, and I'm going to exit 69. So let's fucking go. All right. So this is main. So it contains main. I wish there was like a quick way to sort of shift a thing around. Is there something like, I don't even know. So essentially, I would like to have this function. So you have access and you accept a pointer to a string. And what you get is another string. So first of all, maybe you don't even have to do any assertions or anything like that. You probably, will this thing auto-dereference if I do something like that? So that's a very good question. Maybe not. Maybe it will. So can you index the pointers in Jai? I think you can index the pointers, so I'm not really sure how exactly this is going to work out. So and then what we do, I want to kind of take a slice of this entire thing. Is there some... it's not going to work that easily. So I only implement my favorite, like a shift macro in knob, in the sense that I want to be able to do the following thing, like shift args and get the first arg. And the first arg is obviously going to be program name. All right, so then later I can just like parse it even further. I can just do something like args count. So why not data plus 1? Data plus 1 is not enough. You also have to do count minus 1. All right, so here's the thing. You also have to do count minus 1. So we can use that as an idea though. We can use that as an idea. So you can just take a pointer to this entire thing. Then we can take an access count and we can assert that this thing is greater than 0. So then our result is going to be, so this one has to be a string. Result is going to be access data. Then we do access data plus 1 and count minus 1. And then I return the result. And the result, I expect it to be a pointer, but I hope it's going to go into auto-dereference. Yeah, it's going to auto-dereference. So now, if this thing is greater or equal than 0, we can say something like usage, program, URL. And then we can print error, expected URL, Gemini URL, and then we exit with 69. So this is how we can do all of that stuff, right? So I forgot to semicolon, but so also print, and it didn't auto-dereference, right? So it didn't mismatch in a level and direction, string and dot string. Okay, how do you dereference? It is something like this now, right? So, and I forgot to provide the program name. Look at that, it seems to be working. So now I can do the Gemini thingy, all right? I don't have to recompile the whole thing anymore. Oh yeah, it was it was doing the things. Well, I mean, I have to use that URL now though. Did it make a sound? So exit off. So I have to use that in a request. Where is the request? I suppose what I need to do, I need to use a string builder. All right, so I need to use a string builder as b string builder, something like that, or maybe just something like this. So what's the functions that we have for string builders? String builder. I think it's just string. Where is the string builder defined? I think it's basic. Yeah, got you. Print append. I think it's, yeah, okay, so I can just do append. Append, pointer to this thing, and I can append the URL that we're going to have. So URL shift args. Okay, so this is the URL plus the /r/n. Cool. So then we can do request, which is SB, I think it's just toString. Yeah, builder toString. So, and you have to pass it by pointer because I suppose it just deallocates some stuff, right? So string builder, if I remember correctly, it's like literally a linked list of chunks. It's a linked list of chunks, and when you do toString, it allocates a new buffer and concatenates these chunks into your final string. So Sojin is a master beta. Wait a second. Well, not on Twitch, okay? Right, so so we're gonna do this kind of stuff. All right, so because it's against TOS. All right. So this is data. So loss of information trying to fit. Oh, are you for real? Are we kind of losing some information in here? That's fascinating. Can I just do XX? All right. No proxy or other host or ports. Huh. Yeah, because I didn't provide the correct link. Okay, so that's totally fine. So Gemini. Fascinating. Wait, where's the thing? And what is the 31? So there were codes. Redirect. It looks like a redirect. Did it get redirected? Huh. I feel like I got redirected. Damn. Did it just get? Okay. That's bizarre. I need to probably slash. I need to have a slash. Ah. Wait, was it redirecting me to? It was redirecting me to this one. Bro, now we need to implement redirects. Yeah, so now you can just like continuously like implement different features of the protocol, right? Like redirects or something like that. But you can do them manually. Seriously. So since it's so simple, you can do some of the actions manually in here. What the fuck? This is so cool. Okay, so we can take a look at some software. What kind of software do we have in here? All right, so here's some of the software. A lot of them HTTPS links, but some of them, so we need a low memory Gemini server written in C with interesting security features. Okay, so let's visit it. What do we have? No proxy or other ports. It is kind of down. Okay, so let's go back. Is there any other Gemini things? Okay, Gemini client for Commodore Amiga. Holy shit. Okay. I'm already browsing Gemini Space, guys. Which doesn't exist, as you can see. Is there any Gemini pods alive? Right, so is there anything? No proxying or other host support. Damn, that is sad. So maybe it's all dead. GemGit, a tool to generate static websites. Maybe this one is alive. Oh man, it's such a cool idea, but nobody really implements that. Something wrong with your code. I think it is. I'm an idiot. So I'm a total fucking idiot. Does this mean that I have to parse URL now? I think it does. I think it literally does mean that I have to parse URL. All right, so let's go ahead and try to do that. So can I maybe, is there some string operations that we can employ? Something about prefix. So strip prefix, okay. Prefix begins with. We can try to employ something like this. Begins with. So URL begins with Gemini this thing. Gemini prefix. Gemini prefix like this. If it does, or if it would say it doesn't, we should actually print something. Error, invalid URL does not start with Gemini prefix. I'm not using like a proper URL parsing right now, right, because I just want to quickly implement this entire stuff. Right, so we're going to have some sort of a host, and host, I suppose, is going to be basically data plus Gemini prefix count, but minus that specific count. Right, so we're stripping off this entire thing. And I suppose now it would be kind of nice to maybe split from left by a specific byte. Split from left by a specific byte. It will tell us if it found it and left and right. Okay. So host. Does it accept it by pointer? No, it doesn't have to be pointer. But we're looking for this thing. We're looking for this thing. And it returns the whole, like a triple of things. I suppose we need find, we need left. We don't really need to write though. So I think I'm going to just like literally remove that. So, and this is the host. I'm kind of reassigning it back to host. And if not found, it's yet again invalid URL. Invalid URL. So, and what exactly is going on in here? Maybe it doesn't even matter. All right, so if you didn't find it, that means it's the whole thing, essentially. It's the whole thing. So we need to do experiments. So I'm going to do exit 69, and I'm going to just like print host in here because I want to see how exactly we managed to parse this entire thing. So we need to recompile Linux main like so. So begins with, we need to take the string. All right, host. All right, so can I do that? So this is the host. So if now I do something like this, it still works. So left, so if it didn't find it, left will contain the whole thing. So do they even mention that in the documentation? If no match is found, the return value false. Perfect, perfect. This, John, thank you. This is perfect for my case. Damn, thank you so much. Thank you, thank you, thank you. So, and yeah, so here's the host, and we can just get rid of that host, and there we go. So we just like extracted host out of the URL. So let's go and just like try to recompile the whole thing. And so what you did, like them dynamically compiled on the literals. So it has to be null terminated. God damn. To C string, and it allocates a little bit of memory once, which is kind of fine, So yeah, we can do host sister to C string host, This is a leak that we're probably gonna address a little bit later, because it doesn't really matter. So for a batch program like this one, this leak doesn't matter because it's going to die anyway. But if we're gonna make this client interactive, this leak is gonna be actually significant, right? So because you leak a little bit of memory every time you make a query, so that's not particularly good, right? So we'll have to fix it at some point, but I want to make a sort of like a to-do in here, just fix it later. You can just print host, I guess, but I mean, I still need host sister to pass it into the get address info, and it expects string. So it has a temporary allocator. I don't quite remember. Just a second. So grep. Let's take a look to string. Or am I missing anything? Because it just straight up uses alloc. I could probably do something with the context, right? So, but I'm not sure if it's, yeah. Use double comma. I don't understand. But I mean, this one, is it overloaded? Wait a second. Is toC_string overloaded? I don't see it being overloaded. You can set stuff on context. The fuck? But often you want to do lightweight things, and this syntax is pretty heavy. For example, maybe you want to call join in module, and he's talking. Honestly, like sometimes it feels like John is reading your mind, and this is a probably good indicator of him actually exploring this space, like the possibility space of different things, like very, very extensively, right? He actually tried all of the different things, like painstakingly tried different things in different cases and stuff like that. And okay, so you want to do it like that. This is fucking cool. All right, it's kind of an interesting syntax, but huh. All right. So I dig that. I kind of dig that. So let me put this thing in here then. So it's not going to leak. Well, I mean, it's going to leak within temporary allocator, but in our interactive application, we're going to be resetting temporary allocator anyway on each iteration, so it's totally fine. Okay, thank you so much. All right, I'm doing something weird in here. All right, so here's the host. So yeah, that's totally fine. Ooh, access denied. So, but what kind of SSL we're using? That's very weird. But anyway, so let's take a look at some other. Oh, maybe I have to do this kind of thing. Nah, it didn't work. So let's take a look at this software that we have in here. So other Gemini things. So we're gonna take this Gemini thing and I'm gonna put it in here. Could not get address of. That was bizarre, but okay. All right, so can we get a different working Gemini website today? Right, but because I would like to query some other Gemini websites. Wrong or malformed host. Why would it be the client that works only for one website? Exactly. That's bizarre. Right, so am I missing something? Like, because this works fine for some things in here. So yeah, still nothing except the head website. Yeah, it's a very nerdy thing, honestly. And it doesn't accept like my self-signed SSL thingy. Only Gemini.net accepts that. God damn. Right, so let's take a look at some other things. Documentation. Let's take a look at the docs. So the protocol specification, resources for developers, translations, and some. So I think it does it already when you increment. All right, so this we already tried that. We should let me save the software. Gem text. I think that's what it is, right? So it's a software gem text because I don't want to be like requerying it over and over again. All right. So what's up with that? Can we get at least one working? Finally. We get some other website working. This is actually kind of cool. So detonation intrusive obedient Haskell small client. Okay, so we can take a look at readme Gemini. Readme GMI. Okay, so here is the readme. So features, building. Okay, so this is in Haskell. This is in Haskell. Can I get the source code of this thing? Is there any way for me to get the source code? So the changelog. So here's the Git repo. Okay, so that means I can do git clone. All right, I just git clone it. I learned about this Git repo using entirely Gemini protocol with self-written client, and I found some source code. I just found some source code and I just cloned it in here. So here's the source code of another Gemini client written in Haskell. Man, this is so exciting. Like it's kind of cool exploring some web space without a freaking browser, right? It's just like you in your console or something like that. This is so exciting. I don't know why it really excites me. Okay, so we found some repo in here. So this is a source code bundle. So this is instructions on how to build it and stuff like that. So by SSH, you can SSH in here. Can you SSH in here? Is that safe even? Oh, you can use it through SSH. Wait a freaking second. I want to try that. All right. Okay. So I suppose it doesn't really show anything special. Yo, this is cool. Just a second. I'm just afraid that it's going to... you can use this thing through SSH. So you can do SSH. And I'm okay. So I already kind of accepted the certification, so it doesn't show. It was showing the fingerprint of my public certificate, but I think it's not a sensitive information. Like fingerprint of the public certificate is fine. So Gemini, all right. So yeah, okay. Certificate chain. This one expires. No certificate previously seen. Apparently trust provided certificate. Okay, so yes. Project Gemini has moved. This server Gemini has no longer. Okay. So essentially you can just, you know, search for things. Right. Can I just say all right. Okay, so if you don't have a Gemini client, you can SSH in here with the password Gemini, and you can use a Gemini client through SSH. It's so fucking dope. Oh shit. This is so cool. It's so creative as well. All right, so can I just do docs? And you can. Oh, you have to provide the whole thing. But can you do docs? Oh, okay. So if you do .docs, you are within a single website. Then I can go into FAQ of the Gemini, and yeah. So in over there, can I quit now? And it even automatically understands quit. Man, this is so cool. I don't know why it makes me excited, but it's just like small nerdy thing like that. That's what makes me excited. None of the next like an OpenAI model or any shit like that. It's just like it's so fucking boring. This is what makes me excited. Just nerds doing like small nerdy creative thing. It's so fucking cool, isn't it? You can write a crawler on all of this website. You can build a search engine over that. You can kind of build like a miniature web version of the web out of that. So I don't know. The indices on the left of the, oh, you can just use the indices. You can just use the numbers. So yeah, that's kind of cool. So what am I thinking? I think I need to upload the source code of this thing to the GitHub, right? So it's called Voronoi, right? So I suppose this thing should be also called Voronoi. And if I try to build Voronoi like this, is it going to create the, yeah, so it creates the Voronoi executable. So readme md and Voronoi simple Gemini browser. It's not really finished yet. So how do I indicate that something is unfinished? There was a syntax for that on GitHub. So the software isn't finished, keep your expectation low. Yeah. So quick start, and it's simply Jai Voronoi Jai, and then Voronoi. We can just provide the link to here, Gemini, like this. So it works only for a specific version of Jai. So I think it makes sense to actually specify what version it works for. So this is the version that we're kind of expecting here. So regarding the license, let's use MIT, because whatever. And I'm going to git ignore .build. Right. So also probably I'm going to git ignore the executable self. Git init. All right, and let's do commit. Untracked file. So this is this stuff. Ready, set, go. And let's create the repo. Let's create the repo. On GitHub, we commonly indicate the software is unfinished by putting a picture of Goatse in the README. I'll keep that in mind. Thank you. Thank you. Thank you. Thank you. All right. So Voronoi Browser. Simple Gemini Browser. It's public. Okay, good. So add origin. Boom. And let's push that. Is it ready? Is it ready? Is it already there? Is it already? Okay, it's there. Chat. It's up. It is actually up. So it took us like 2 hours to implement this, I think. And description. So here's the source code. That's pretty cool. That's pretty cool. All right, so I guess that's it. So we should probably rate somebody. Do any recreational programmers streaming right now? Do we have any recreational programmers streaming? Don't really see anybody. Oh, Last Miles is streaming and he's doing OpenSSL. That's fucking perfect, bravo. Bravsky. So Last Miles. So I'm gonna redirect you guys to a Unix wizard. So be nice to him. He's very wise. Likes to drink a lot, but he's still very wise. So I'm gonna do raid Last Miles. All right. Get ready for the raid. And I see you all on the next recreation programming session with Ahu Amista Azozin. I love you all. Mwah.